So today's video is about mean absolute deviation. So what is the mean absolute deviation, or MAD abbreviated? One way to find how consistent a set of data is to find the mean absolute deviation. So let's kind of break it down some. What is deviation? Well, deviation is the difference between one of a set of values and some fixed value. And a fixed value would be a number that doesn't change. So it would be the fixed value, which is your number that's not changing, and the deviation is how far the other numbers are from that number. So the mean absolute deviation is the average distance each number in a data set is from the mean. And another important word is the word variability. And variability refers to how spread out a group of scores is. So variability would be if you have the difference between the different numbers. Is there a large difference between all of the numbers, or is there a small difference? And that would be how you would describe the variability. If something has a lot of variability, that means there's a large difference between a lot of the numbers. And a small variability means that there would be a small difference between the numbers. So what does the mean absolute deviation tell you about your set of data? So the mean is supposed to be a description of what the typical number is for that set of data. So you expect most of the values to be close to the mean. And so a low mean absolute deviation indicates that the data points tend to be very close to the mean and not spread out very far. So the mean, we would consider the mean then to be an accurate description of typical, what will be typical for that set of data. A high mean absolute deviation indicates that the data points are spread out over a large range of values, and in this case the mean would not be an accurate description of the data. And then that would be a set of data where you obviously have some outliers that are affecting your data. So how do you find the mean absolute deviation? The first step is you have to find the mean of the data set, and we do know how to find the mean. Step 2, you're going to subtract the mean from each value in the set of data. You may have a negative number in your answer, but that's okay, because step 3, you're going to give the absolute value of each difference. And we know absolute value is distance, and we know distance can't be negative. So even if you end up with the negative number in step 2, in step 3, that number will become positive. And then step 4 is to find the mean of those differences. So example 1, the following data represents the sizes of 9 different families. Find the mean absolute deviation. So these are all the sizes of these different families. So we have one family with 3 people, one with 2, one with 4, another with 2, one with 9, one with 8, one with 2, then we have one with 11, and then we have one with 4. So our first step is we want to find the mean of the data set. So of course, to find the mean, first we're going to add up all of the numbers in our data set. Then we're going to divide that by the number of numbers, and since it's 9 families, we know that would be 9 pieces of data. So we're going to do 45 divided by 9 and get 5. So that means the mean, or the average size of these families, would be 5. So now that we have found the mean, we're going to go on to step 2. Step 2 says that we subtract the mean from each value in the set of data. And remember, don't worry if you get a negative number. This value is the deviation from the mean. So the mean is that fixed point that we talked about at the beginning of the video. And the deviation is how far each one of these numbers is from the mean. So if we start with our first value, 3, we're going to do 3, and we're going to subtract 5 from it, which means the deviation would be negative 2, because 3 minus 5 gives you negative 2. So right now that is 2 places from the mean. Then we have 2 minus 5, which means the deviation would be negative 3. The next value is 4, so then 4 minus 5 means the deviation would be negative 1. The next family is 2, so again 2 minus 5 would give us negative 3. The next family has 9, so then we're going to do 9 minus 5, which gives us a positive 4. The next family has 8, so we'll do 8 minus 5, and that gives us 3. Then again, we're going to do 2 minus 5, and that gives us negative 3. Then our next family has 11, so we're going to do 11 minus 5, and that gives us 6. And then our last family has 4, and we're going to do 4 minus 5, and that gives us negative 1. So again, you may end up with a negative number in this step, but don't worry, when we get to step 3, they will change to positive. So then the third step is to find the absolute value of the differences. Remember, absolute value is about distance, and distance cannot be a negative number. So the question is, what is distance negative 2 is from 0? So the absolute value would be 2. And then the absolute value of negative 3 is positive 3. The absolute value of negative 1 is positive 1. The absolute value of negative 3 is positive 3. The absolute value of positive 4 is positive 4. The absolute value of positive 3 is positive 3. The absolute value of negative 3 is positive 3. The absolute value of 6 is 6. And the absolute value of negative 1 is positive 1. So the third step is that we need to find the absolute value of those deviations, which basically means all the positives will stay positive, but all the negative numbers need to become positive numbers. So now step 4 means to find the mean of the differences. So this column here in the yellow, we're going to find the mean of these numbers in the column. So the first step is to add up all the numbers in the last column, and that gives us 26. And then we're going to divide by the number of numbers. So we're going to divide by 9, which gives us 2.89. So what that means is the mean absolute deviation, or the average deviation that each of the families are from the mean, which is 5, is about 2.89, or about 3. So what does our answer mean? So 5 here represents the mean. That is our fixed value. So we would say, based on the data that we have, that the average family has about 5 people in it. So then the absolute deviation would be that most of the data points are either plus 2.89, so that would put us between 5 and 7.89, or basically between 5 and 8, or it's a minus 2.89, which will put us anywhere between 5 and a little over 2. So what that means is that most of the families that we interviewed, of those 9 families, lie somewhere between basically between 2 and 8. And that would be a good description of the data that we have, because if we look back at this table in our very first set, most of the values do land somewhere between 2 and 8. We have a couple that land outside of it, but most of them land between 2 and 8. So again, what that tells us is that because most of our original data falls within plus or minus 2.89 points from 5, we could say that 5 was pretty much a good description of the data that we have, because that is what we would consider to be a low mean absolute deviation. The closer you are to 0, the better the mean absolute deviation.